Today I'm going to be showing you how to build the best air compressor for your money. This is actually a pretty powerful compressor. It puts out like 10 or 11 CFM. So $100 for that, $100. Your compressor tank, $50. Miscellaneous parts, $50. $300 total. So what you want to do is you first want to screw your compressor to the board and your motor to the board. You can use steel if you want. You could get away with wood, the equation. So a lot of people use like, I don't know, 1/8" steel. This board is a lot stronger than 1/8" steel plate. It's much thicker. Even though wood's weaker than steel, it is stronger based on that. Then you want to adjust your belt tension. So you want to pull this motor all the way back and then screw that in. You want a good tension on your belt. Then what you want to do is you want to plumb your compressor to the tank. Sorry, this is a water heater hose. This inside diameter is 3/4 of an inch. My old restricted by that. So then, yeah, so this is washing the water heater hose. Then you have this water heater hose valve then goes into check valve into the tank. What does the check valve do? It prevents, once this motor turns off, it prevents the air from the tank back feeding into the line and spinning the motor and compressor backwards. So you need a check valve. That's non-negotiable. The next thing you want is a unloader valve, which we'll talk about later, but I built my own. Is the pressure cutoff. So you're going to want to wire your motor to the pressure cutoff assembly so that your motor can turn on and off at the set pressure. So I have mine where it turns on at like 60 psi when the tank drains, and it cuts off at 110. How do you set that? Well, this attaches to here and gets the air pressure. So pressure is force over area. So this has a certain area. So this is exerting like 50 pounds or a certain level of force on the spring, probably like 5 pounds, sorry. So when the force of the spring is exceeds the force of the air, then this contactor here is closed. When the air pressure in the system overrides that spring, it's open. And what do? You adjust the spring pressure basically with this screw. You kind of then wiring, just follow this. It comes with a wiring diagram, but it's really basic, the wiring. You have 2 terminals. This goes to the motor, 2 upper ones. This is motor hot, motor neutral, and then the bottom is the outlet hot and the outlet neutral, as you can see there. So yeah, that's that. So that basically controls the motor, and then this box gets the live power from the wall. This is actually 240 volts. I use a 110 plug because it makes my life easier plugging to extension cords and stuff. It works. So then this controls the motor. So the issue is when this turns off at the set pressure, there's still air in here. That air pressure would be equivalent to your tank pressure, which is an issue because when you want your compressor motor to turn on, if this is like 60 psi, that's a lot of force pushing back against this pump, and your motor is going to have to work hard. And so you want an unloader valve, which will discharge this excess air pressure, so that when this motor always turns on, there's no pressure here. So how do you do an unloader valve? You could buy one, or you could just drill a hole in here. So I drilled a 0.04" hole. And then I put a paper clip in there. That's what I did. So you could read on the actual unloader valves you buy, it's like a 0.04" hole. My drill bits my chuck can't fit a 0.04 drill, so I put a 0.05, and then I put a paper clip in there, and that made it 0.04 by subtracting the area of the hole minus the area of the paper clip. But yeah, and the question is, will that reduce tank performance? Because the unloader valves you buy from the store, they actually aren't really a hole. They have a spring and a hole, and it only drains at a certain pressure, right? So I did a test. I measured how long it took to fill the tank without this hole drilled and how long it took with the hole drilled, and there was no difference. It was 1:30 each. Why I figured it wouldn't matter before is because this is actually resistors in parallel. So your tank resistor is a really high resistor, like 1,000,000 ohms or like 10,000 ohms, and this is like really low, and they're in parallel, and there's really not much air draining through there. It's not, the electricity or the air is going to take this path. It's really not going to want to take that path, or not too much air is going to take that path. So yeah, it's fine. It really doesn't impact performance, and you get a huge performance gain by having that there, because now your motor can work easier. The next thing is you want to make sure when you have it on the board, this will vibrate like crazy. This board is a little warped, which even makes it worse, but what you do to fix that is I had these rubber strips that I put on underneath the board. So yeah, so those rubber strips prevent the vibrations because the friction resists this kind of wobbling. You don't have to put that much. The friction is mu times mg, so mg is your weight. So there's nothing to do with area of the strip. So you could put in as small a strip as you want. All that matters is the material of the strip, if it's rubber or, etc. So then I originally had just strips of rubber, but then I put a rubber underneath because that's even better. Because rubber on concrete, the coefficient of friction, let's say, is 0.1. Rubber on rubber is nearly 1. So with this rubber of this on the board and the rubber mat, this thing doesn't go anywhere. So I like this setup. It's good and it works. And let me show you. You can see the unloader is discharging the air. See that little hole that I have? So yeah, it works. There you go. Questions, put them in the comments. You have your drain valve, forgot, and regulator, etc. and etc. Have a good day.